Welcome to class number 53. We're going to differentiate elastic and inelastic collisions, and we're going to use conservation of momentum to calculate velocity and mass. So we said that elastic collisions are collisions where the two objects come together and bounce off each other, and inelastic collisions are when they come together and stick together. So what we did in this part of class was we looked at an elastic collision and then an inelastic collision, and we wanted to determine, was momentum conserved in both of those types of collisions? Remember, momentum is conserved when there is no net force acting on the system. All right. So we used the simulation, and what we did was we did a situation where we had a 5 kilogram object going at 1 meter per second to the right, approached a 5 kilogram object that was stationary. So we found the initial momentum of the system, which is just adding up the momentum of each one. So 5 and 0, because 5 times 0 is 0. So the initial momentum of the system was 5. Then we let the two of them collide. After they collided, the 5 kilogram one was no longer moving. The one on the left was no longer moving, and the one on the right was now moving at 1 meter per second. So the final momentum, we find the momentum of each one, and notice how we end up with 5 kilograms times meters per second. So momentum was conserved in this calculation. By the way, if you're wondering where we got 5 kilograms from, I just said in the simulation, since it just has m, 2m, 3m, to make m equal to 5. All right, you may have used different numbers when you did it with your group. So m is 5, 2m is 10, 3m is 15. Now the inelastic collision, we did it basically the same way. So we had the 5 kilogram object going to the right at 1 meter per second, and the other one was stationary. So the initial momentum of the system is 5, right? 5 times 1 is 5, 5 times 0 is 0, 5 plus 0 is 5. Now, looking at the final momentum of the system, we have, let's see, well, now the objects stick together, an inelastic collision. So when two objects stick together, we know that they have the exact same velocity. So mass times velocity is 1. They each have a mass of 5 kilograms, and they each have a velocity of 0.5. So 5 times 0.5 plus 5 times 0.5 is 5 kilograms times meters per second. Another way some teachers do it is they just combine those two immediately and say that's one 10 kilogram mass going 0.5 meters per second, which is fine, and you can do that. And they get 5 kilograms times meters per second. So momentum is also conserved in inelastic collisions. Now we should expect this because there are no external forces in these two types of collisions. The third type of collision isn't really a collision at all. It's actually what we call, quote unquote, an explosion, where the initial momentum of the system is 0. Therefore, the final momentum of the system has to be 0. It's an example of it would be like a gun firing. Bullet goes forward, gun recoils backward. Momentum is conserved in that case. We have a situation here where we have two carts, and there's a spring between them, and the spring is released, and they push apart. So there's a before picture and an after picture. This is actually the after picture. All right. The before picture, the two carts are together, 7 kilograms and 3 kilograms, and they are not moving. All right. The initial velocity is 0. The after picture is given in the picture here. 7 kilograms and 3 kilograms. The 3 kilogram cart is going to the right at 6 meters per second, and the 7 kilogram cart is going to the left with a velocity we don't know. So this is how you're going to do every conservation of momentum question. You have your before side and your after side. Your P initial equals P final. So start by writing that down. The next thing you're going to write is M1 V1 plus M2 V2 equals M1 V1 plus M2 V2. Now, if you'd like to, it gets a little bit crowded, but it's a pretty good idea to tag on initials on the velocities here because those change, and finals on the velocities on the right. I am not going to do that because it does get very crowded. But if you can remember that the left side is initial and the right side is final, you'll be just fine for this class. All right, so how do we fill these in now? Well, on the left-hand side, M1 and V1, this is, let me use purple, different color. This is M1, and it's not moving initially. So you have that there, 7 times 0. And the 3 kilogram cart isn't moving either. So you have 3 times 0. After they're released, the 3 kilogram car is going 6 meters per second. So I throw that over here. And the 7 kilogram car is, well, we don't know its velocity. All right. So that's how we fill this in. We take our before picture, use it to plug in values on the before side. And we have the after picture, use that to plug in values on the after side. We have one unknown. Work through the algebra here, and you should end up getting that the velocity of cart A is negative 2.57 meters per second, which should make sense to you because, well, it's going to the left, right? If positive 6 meters per second is to the right, that means anything going to the left would be a negative velocity. All right, so we have some extra practice here. So this one actually gives us a before and an after picture, which is great. One thing I did with all the classes, as I said, make sure you convert all of these masses to kilograms. You actually don't need to, but I don't want to get into that. Just get in a very good habit of converting all your masses. So this is 0.1 kilograms going to the right at 4 meters per second. This is 0.15 kilograms, and it's stationary. Okay, the question tells us that it's stationary. It's a stationary block B. After the collision, block A, which again, 0.1 kilograms, is going to the left at 1.5 meters per second. I would make that velocity negative, okay, because right is positive, left has to be negative. You cannot get the right answer if you don't make that negative. And we're looking for the velocity of block B after they collide. Again, this is 0.15 kilograms. So we need to calculate the velocity of block B. We don't know its velocity. I don't know if it's going left, right, what's going on. Actually, you can kind of tell intuitively that it's going to go to the right, but we don't really know. So start with Pi equals Pf. M1v1 plus M2v2 equals M1v1 plus M2v2. So just go to the pictures, right? Right here. Those numbers go in right here. Mass and velocity right here. Your after picture, these numbers go right here and right here. And our unknown is V2. Work through your algebra and you get V2 is equal to 3.67 meters per second. Next question here, we have a 5 kilogram cart going 20 meters per second, and it hits a cart of unknown mass that is traveling at 10 meters per second in the same direction. They're not going towards each other. It's kind of like this 5 kilogram cart is catching up to it. After they collide, the 5 kilogram cart loses some of its speed. It lost some of its momentum. It transferred it. So it's only going 10 meters per second now. But the M2 is now going 15 meters per second because it took some of the momentum from the cart on the left, the 5 kilogram cart. So again, same exact process. Pi equals Pf, M1v1 plus M2v2 equals M1v1 plus M2v2. Working through it here, we have this 5 kilogram one. That's what gets plugged in here. We have 10 times M2. That gets plugged in here. Then 5 times 10 plugged in right there. M2 times 5, or 15 rather, gets plugged in right there. Working through it, you should get that M2 is equal to 10 kilograms. And last but not least, we have two carts going towards each other. One is 2 kilograms going 6 meters per second to the east, and the other one is 3 kilograms going an unknown speed due west. After they collide, this is important, they stop, they come to rest. So their final velocities are 0. So let's start the same way. Don't do anything new. Pi equals Pf, M1v1 plus M2v2 equals M1v1 plus M2v2. And then you just plug in. These values go here. These values go here. Then realize the whole right side is 0 because your after picture, well, 2 times 0 plus 3 times 0 is just 0. Work through your algebra, you should get negative 4 meters per second, which tells you it's going west. All right, so make sure you're able to work through these on your own. I know I didn't work through them with you, but make sure you follow the exact same process I did. Start with these two lines every time. Pi equals Pf, M1v1 plus M2v2 equals M1v1 plus M2v2. It'll always be useful for conservation momentum questions.